Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a concept in mathematics by the name indices. Now some specific expressions are written to powers of particular numbers, or some variables can be raised to particular powers, and these are generally what we refer to as indices. We are going to look at the specific rules which are going to be applied in so far as indices are concerned in all of their operations and how we can be able to treat them in regards to other numbers. So for that case, thank you and welcome. So today our topic of interest for today is going to be indices. And in trying to look at indices, by definition, an index refers to an index refers to an expression that is written in the form of, so this is an expression that is written in the form of a raised to power n, that is defined as a variable that is raised to a power of a number n, where n of course implies to a power, or what we can refer to as an index, or of course what we call an exponent of a. So therefore equations or expressions that assume the form of a raised to power n, where n is a power, an index, or an exponent of a, that is what we call an index or an index. For example, we can have an expression of this form whereby we have this general number variable that we refer to as a raised to power 1, which of course let's say is equals to a. Therefore that expression is what we refer to as an index. If we have a raised to power 2, this one implies a times a, and then a to power 3, a times a times a. Now this one leads us to the general expression that we have talked about of a variable a that is raised to a power of the number of n, which is going to give us of course a particular value, maybe let's say x. So therefore this kind of an expression is what we call an index. Now there are specific rules that indices must satisfy for them to be used in solving, of course, different kinds of expressions, or maybe problems that we may encounter that require the use of indices. And we're going to see that there's a relationship between these indices and the logarithms when we try to compare. Now that we said logarithms are a mirror image of exponential functions that we had, of course, done in one of our videos. So in this case, rule number 1, when we have n as a positive whole number for an expression that we had written as an example a raised to power n, then this implies that a has been multiplied n times. So therefore this applies all across. For instance, if we have a number x raised to power n, this implies that x has been multiplied y times. So therefore expressions are going to assume that format. And then we have maybe, for instance, I've talked about where n is a positive whole number, then this rule is applicable. It is going to be a raised to power n. Suppose n is a negative number, then what form of a... Now this is for positive powers. Now suppose n is a negative number, and how are we going to, of course, give it? So we say that a raised to power n. Suppose n is the first one, that's the first expression, then we are going to have a. This applies for positive powers where n is equals 1. And then for negative powers, suppose we have a raised to negative n. Then this one can be written as 1 over a raised to power n. For instance, we have a raised to power negative 2, and this is going to be 1 over a raised to 2. So negative powers of that form are going to be treated as such. And then number 3, we have what we call 0 powers, or 0 power. And this is a basic rule that, of course, we have been coming across in a range of our discussion. So we have a number that is raised to power 0 gives us 1. So where x represents a number that is raised to 0 is equals 1. So all indices must satisfy the rules that we have mentioned in mathematical applications. So therefore, trying to create an emphasis for this, we're also going to see that these are some of the rules which are going to be applied in logarithmic functions. So suppose we have an expression of this form. I can just divide this one into this, so for convenience. So suppose, let's try to look at some specific rules. Suppose we have a raised to power m and a raised to power n. We can see that these numbers, which are variables, are the same, but the exponents or the indices are different. So in this case, for such a kind of a product that we are being requested to find, then we treat it as the sum of those exponents. So therefore, a raised to power m times a raised to power n is equivalent to a, the sum of that product. So this is not going to be known as the product of powers. For these two, then it's addition. So suppose, for example, we have 2 raised to power 2 and 2 raised to power 3. Then this is going to be 2 raised to power 3 plus 2, which is 2 raised to power 5, which is 32. So this is a rule that is going to be applied. So there's a different rule also that we are going to look at, whereby we have a fraction. This is rule number 2. Suppose we have a raised to power m over a raised to power n. We have the same variables, and therefore we are going to have a m minus n. So for division, this is a difference. For addition, for multiplication, is an addition. So those two rules are going to apply. So therefore, how can we be able to treat an expression or an expression of that nature? So that is going to be, we see for a fraction like 2 raised to 1 is the same as a half. So therefore, we are going to just write this as a negative m minus n, and that is going to apply as such. So there's also rule number 3 that we have to look at for the indices that's applicable for all mathematical treatment of these indices, or mathematical application for these indices. That is rule number 3, whereby we have a raised to power m, of course, into exponents of n. This is going to be a m, the product of the two. So in case we have a power that is being multiplied by another power of power, then we are going to have that rule apply. In this case, this is a quotient. The rule number 2 is basically a quotient. this is a quotient of a power. The first one we said it was a product of a power. The second one we have said it's of course a quotient of a power, and the third one is a power of another power, which is going to be written like that. For example, suppose we have 2 raised to power 3 which has been squared, then we will have 3 times 2, which is 2 raised to power 6. That is going to give us 64. So this is the way we are going to treat such a kind of problems in all mathematical applications. So suppose we have different variables but the same power, then we are going to apply another rule, and that is rule number 4, which is of course a raised to n, b raised to m. Or maybe just different, we have different variables but the same exponent. This is going to be given as ab raised to n, and this is known as the power for product. Power for product rule. For example, suppose we have 3 raised to power 2 times 4 raised to power 2. So this basically from the just this 9 times, of course 16. So 16 by 9. This is 144. So in this case, if we try to look at whether this rule apply, then we shall have 3 times 4. This is a squared, which is a product of 12 squared, which is 144. So this rule is applicable this way, and therefore we are going to use it. Suppose we have a power of a quotient. We have stated this one as a quotient rule. Of course, this the one that we had written, that is a. Of course, we had written as a raised to power m divided by a raised to power n. And this we said the quotient rule applies. Now, suppose we have a power, a quotient that has been raised to a power, then how can we be able to treat that one? So we are going to have a raised to power n over b raised to power n. This is going to be a over b raised to power n. Now, in this case, this is only applicable when b is not equals to 0. Of course, for fractions, we say that if that is 0, then it is indeterminate. We cannot be able to determine the number for that. For example, if we have 6 raised to power 2 over 3 raised to power 2, then this is going to give us 6 over 3 raised to power 2, which is 2 raised to power 2, which is 4. So that is how the power over quotient rule applies. So these specific rules, as I have said, are going to be applicable in all mathematics applications. And there's a deep relationship between the logarithmic and exponential functions that I've mentioned before. So we are going to see how this relationship works whenever we tackle a problem that is related to logarithms and indices. So that is it for today, guys. Thanks. Bye. God bless you.